Hi, this is Steve Irwin with GoEngineer, and today I would like to present to you customer replaceable print tips and other items that are replaceable by the customer within the printer. These items can be replaced in uPrints, Dimension 1200s, and Fortus 250s. To start out with, I believe the first thing we'll talk about is the majority of the conversation for this particular presentation. The ability to replace model and support tip inside of your 3D printer. The typical replacement time is suggested at 2,000 build hours. There's another replaceable customer item called a tip shield. The tip shield is the little piece of plastic that goes on the bottom of the tip itself and keeps material from collecting on the bottom of the tip. That should be replaced at 500 hours. The tip wipe assembly is another item that can be replaced by the customer, and it is replaced at 500 build hours as well. So how do you know when it's time to replace any of these customer replaceable items? These things can be checked either in a manual process, if you use a manual technique. If you have a Fortus 250 printer, you can use the control center to find out how many build hours are on the tips. With a uPrint or with a 1200, you can actually use the Catalyst software to check this item. Now, if you don't use the manual method to verify the time on the build tips, you can actually wait till preventative maintenance alerts show up on your computer, and along with the alert showing you the item that needs replacing is an associated part number, so you'll know how to order those items beforehand or after. So from a Fortus 250, if you're connected with that on your computer, you would see 4 tabs inside of the Control Center software. The 4th tab, which is the Services tab, has a button on it called System Information. If you select that button, you will get a dialog box that displays showing you the odometer with the amount of tip build hours that have built up on your tip. So if you look at this particular machine, it has 1,525 hours and 50 minutes. So getting close to the 2,000 hour max, but not there yet. This would be another way that you could also find out when it would be time to change the items that are changeable at 500 hours. So at every 500 tick off of the odometer, you could go in and change those items, being the tip wipe or the tip shields. Now if you have a uPrint or a 1200, you would be checking this through CatalystEx. And in this particular instance, we have a uPrint, and inside of the CatalystEx there are 5 tabs. The 5th tab being the one for printer services, where you'll be able to find printer info. Once you select on the printer information tab or button, it will show you the odometer setting for the tips in that particular machine. As you can tell, the tip hours are very low on the uPrint. This particular machine was recently installed in our office and has had very little use yet. This is an example of the screen you might see on your computer that is connected to your 3D printer. You might see an identification saying that the tip wipe is ready to be replaced, or tip shields, or extrusion tips. And then the number off to the right hand side would represent the part number that could be used to order those items from our supplies email. So our supply email is supplies@goengineer.com. So let's go ahead and look in depth more at the tip wipe. That's one of the easiest things to replace. So there are two basic methods for replacing the tip wipe assembly. One is powering down the printer. The other would be to leave the printer turned on and use the maintenance mode from the front panel of the printer. So if you're using the power down option, then you're going to turn the power off on the printer. Once the printer is turned off, you'll be able to open the door of the printer and manually reach inside and move the head away from the purge bucket area. That's where the tip wipe assembly is located. So on the slide here, you'll see on the right the picture of what the tip wipe assembly looks like. Once you can reach in and grab the tip wipe, just lift it up and away from the holder and then throw it away. Then when you're ready to insert the new one, just take and drop it in on, there's two little posts where the old holder came off that will set the tip wipe down on top of the holder. If you choose to leave the printer on, then what you can do is from the front panel of the printer, you can select the maintenance option, which will take us to the next screen, and you'll see a machine option. So you select the machine option. That will cause the head to begin to move in the build environment. The head will be moved automatically to the center of the build volume, away from the purge bucket, so that you can get access to the tip wipe assembly. And then you follow the same tip options as before. Reach in, open the door, reach in, select the tip wipe assembly and pull it up, and then discard it, and then drop in the new tip wipe assembly over the two mounting posts inside the holder. The next item that you might want to replace would be tip shields. So as tip shields are used over time, they become worn or damaged and they need replacing. Again, that typically happens around 500 build hours. You'll notice the picture that we have on this slide here. There's a good bit of buildup of support on that underside of the tip shield. So it would be a good time to change that tip shield out, even if you haven't gotten the notification from the preventive maintenance warning. So to go through the process of removing the tip shields, you'll want to again go into the maintenance mode from the front panel of the printer. From there you'll select the machine option, which moves the head out to the center of the build chamber, allowing it to have more easy access. You'll also notice that the Z platform will also move at the same time. So the next step would be to go in and start removing the front cover of the print head. That just covers up all the detail information behind it, so that you'll notice there's a little triangle over there, and it'll have a little warning sign on it, basically letting you know that it's a hot area or a warm area. So if you have very large hands, you might be able to use two of your fingers on your hand to span the width of the tip cover and press in a tab on each side, and then pull the cover off towards you. If you can't, you might have to use two hands and just use a finger on each hand to depress the little tabs and then remove the cover. Once the cover is removed, you will see that a little bit more detail here on this picture. I've we've got a close-up so that you can see the little tip shields or the plastic piece on the bottom, and then you'll see there's a little arrow pointing to a tip plate, which is a metal piece that's associated with the tip itself. What you can do is you can use a small screwdriver or a pocket knife or something to that effect, and you can use it to pry between the tip plate and the tip shield. You'll just work it off and pry it off, each of the tips. Then you can replace the tips with fresh tip covers, shields that you have. After you've removed the tip shields, there is a wire brush that has been supplied in your startup kit, and you can use that to rub off any debris that might have built up between the tip shield and the actual tip plate. It may not be there, but if it is, you can use that little wire brush to scrub it and remove the debris. Now the new tip covers, tip shields, this is what the picture looks like for the tip shields. You'll notice that there's a little sort of rectangular shapes at one side of the underside of the tip shield, and little sort of grooves in there, slots that you want to be able to position those towards the back of the machine when you put those tip shields onto the tips. So once you've replaced the tip shields, you're ready to put the cover back in place on the printer, and then use the front panel maintenance options and press done until you've backed up all the way back to the idle screen. So now we're going to start looking at the actual replacement of the tips themselves. Again, they should be replaced at approximately 2,000 build hours. Whenever you replace the tips, there are a couple of calibrations that are required to be run. All of this will be automated as part of the process of running the tip replacement from the front panel of the printer. One of the calibrations that will be run is called Calibrate Z. The other one is called Calibrate XY. So to begin the process of changing the tips, you'll start out by selecting the machine option from the very first idle screen, which will take you to the next screen showing the maintenance option, and then the next screen will show the machine option, and then the third screen will show the tip option. So at this point we'll select tip, and then that will bring us to the tip screen. Once we're on our tip screen, then we want to select the replace option, and then you'll start to see the screens change a little bit. So you'll see at the top of your screen it'll say material unload, unloading support. So the first thing it unloads is the support, followed by material unload, unloading the model. Then you'll see a variety of other screens. During that process you'll see material unload, remove support cartridge. So you just depress in the support cartridge, and that releases the mechanism for that cartridge. Same thing with the model cartridge. It'll say unloading, remove cartridge. You don't have to take the cartridge all the way out. You can actually just depress it and let it disengage itself. At that point it will come up saying maintenance and warming up. Once the machine reaches temperature for replacing the tips, the screen will change to say maintenance, replace tips. So that's your cue to go in and start doing the process of replacing the tips. So the first step, assuming that we haven't done any of the other items to be replaced, and we're just now going out to replace the tips, is to remove the plastic cover on the head. Once the plastic cover is removed, then you'll utilize a 7/64 T-handle Allen wrench to loosen the heater block screws. And you want to be able to loosen them a full 3 to 4 turns but you do not want to actually remove the screws. You want to leave them attached. Basically, the heater blocks are clamps that clamp in the tips and hold them in place. So once they're loosened, then you'll be able to remove the tips. So typically you would do this one tip at a time. You wouldn't loosen all 4 screws, then take the tips out. You'd loosen 2 screws, take 1 tip out, loosen the other 2 screws, and take that tip out. Doesn't make any difference whether you remove the model tip or the support tip first. Doesn't make any difference. Once you've gotten the screws loosed, then what you want to do is take a pair of needle nose pliers. Typically there will be one included inside of your startup kit. Grasp the tip shield and the little metal portion of the tip, and then pull the tip toward you and down and out. You can throw that tip away if it's had those 2,000 hours on it. That's why we're replacing them. Now for the case of there is one printer that's different than all of the other printers that we sell. It's called a BST, which stands for breakaway support type printers. And those printers use the same tip for each side, for the model side tip and for the support side tip. But all the other printers that we sell are soluble type printers, meaning that the support material can be dissolved away in a water bath. In these types of printers, you'll have a tip that is different than the model tip, and it will have the word support printed on the tip, like this picture here. So you can see the word soluble has been printed on the top side of the tip that's going to come in contact with the heater block. At this time would be a really good time before you actually put the tips inside of the printer. It would be a very good idea to go ahead and install the tip shields. When you replace the tips, you're probably replacing the shields at the same time. So you would press those shields into place prior to inserting the tips inside the heater block. So with the new shields in place, you'll notice that the little arrows there pointing to the back side of the slotted shape on the tip shields. Of course, it doesn't make any difference whenever you put the tips in. They can spin around, but make sure the back side of the slotted shields are towards the back of the printer. Now, one thing to note about the tips is they have a little collar around them near the bottom of the tip. That's to actually set and engage inside of a groove inside the heater blocks. So when you put the tips in, you want to push them up and then backwards to engage them inside of that little groove area. And then at that point you want to go ahead and tighten up the screws to fully fix the tip in place. So here is just reiterating the fact that once we push those tips in, we want them flush to the bottom of the heater block, and using that T-handle again, we want to tighten those screws back down so that the tips are good and firm inside the heater blocks. So after you've replaced the tips, you're ready to go ahead and put the cover back on. You'll close the front door, and when you close the door after going through the mechanics of changing the tips, that signals the printer to change the front panel of the printer to say something different. So at this point, it changes the front panel so that it says tips replaced, ? Did you complete the process? At this point, you want to say yes, and whenever you select the yes option, that's the time that it goes in and resets the tip odometer to a 0 figure. so that now you'll have a fresh start with those tips, and you can periodically go in through the software and check the odometer. There is no way to check the odometer setting from the front panel of the printer, only from the software. After you've said yes to it, then the front of the printer automatically changes the front panel so that it says Add Remove Material. So now it's time to load the material. So you want to push in both cartridges so that they engage back into the machine, and you can select the Load Both button to tell it to load the materials. After the material has been loaded, then you'll go in and it'll start up the calibration process automatically. You don't have to select anything to tell that to start. So the next thing you'll see is the little picture on the bottom of the page there saying Calibration. It's reminding you it's a good time now to go ahead and install a new fresh modeling base so that it can build the new calibration models on that base. After you have placed in the modeling base and closed the door, the printer will change the front face of the printer so that it flashes Start Part. And it'll actually start the very first calibration when you click the little Start Part button. The first calibration is the Cal Z followed by the Cal XY. So it will show up on the front dialog or the front of the printer saying building the Cal Z. It'll warm up the printer, getting ready to print, and then it will also say building Cal XY. Now when it's actually doing the Cal Z, the picture in the top right there is what the Cal Z plot looks like. It builds a plot on the left, a little box, and that is support material. The little box on the right is the model material. Once the plot is finished, it's a complete automated process. You don't have to do anything. The printer goes out and does all the measurements it needs. It'll actually go out and touch down at multiple places on each block and then touch down on multiple places on the platform to record the Z depth for each subsequent print that happens. The next calibration that runs is that Cal XY, and it prints that little diagram in the lower right of the screen, showing you a plus and a minus Y, a plus and a minus X, and this one actually takes a little bit of user intervention. Once the plot is complete, you take the platform out of the printer, and then you're going to use a little magnifying glass, which I'll show in just a minute, to help you read the plot results. So whenever we take a look at this plot that I've created here in the positive Y and in the negative Y, we'll see that what we're looking for is reading a support bead that runs between two model beads. And here is that magnifying glass that I believe you will probably need to make an accurate reading of this plot. So it's a 10x little magnifier. It comes inside the startup kits for the printers for your convenience. So here, looking at this page, you'll notice I've got an overall view up in the top right-hand corner. So the leftmost picture represents the lower left-hand corner of that plot. So if we look at that plot, you'll see there are two little black beads of material that run around this square. That's where the little arrows are pointing at. And then in between there is a support bead. Where that support bead is best centered between those two beads represents the place or the alignment or the change that you need to make from the front panel of the printer. So if we look at the negative Y, it appears to be pretty close to centered at the 0 point. And then if we look at the positive Y, the same thing is also true. The center bead, or that support bead, runs pretty much right down the middle at the 0 location. So then we move on to look at the negative X or the positive X side of things. So if we look at that, we'll see that the support bead appears to run best centered between the about the 7, positive X7 value. So there's not room to print numbers for each of those locations, so they just imply that there's a 7 in between the 6 and the 8. So after you've read the plot and you've determined what you need to do, you'll notice that you can select between the X and the Y axis by using the select and the axis name. Whenever you select that, it's selecting the axis that's displayed. So right now, X would be active. If I select Y, that will make the Y active. Y was at 0, so we don't need to make any change there. So if I'm on the X already, all I need to do is select the increment button up to 7 times, and that sets that value. You'll notice, or from the previous slide, you saw that that plot went up to 8. So you can only max out at 8. So if the settings are greater than the number, you may have to run this plot a couple of times to guarantee that you have the offset value set correctly. Once you're finished with the calibration, then you select the Done on the front panel and just continue Done until you backed out to the idle state. So that's the completion of the presentation. I hope everyone has enjoyed this. I know that we don't have any other attenders at this time, but we are recording this so that you can watch this at your own leisure in the future. Thank you very much. This has been Steve Irwin with GoEngineer.